Coble, and this is my Project 3 presentation for CE 570. I'm going to quickly review my code from last week with some slight modifications. My shape of choice is a snow cone with an upright cone stacked below a cylinder and hemisphere. As you can see listed, I have modified some of the values from last week, but overall the code remains the same. If you would like to see a further explanation of this code, please see my Project 2 presentation, which discusses this code in detail. Next, I would like to highlight my scalar field, vector field, and tensor field in my MATLAB code. First listed is my scalar field, which is x1 squared plus x2 squared times sine of pi times x3 over 2h, where x1, x2, and x3 correspond to the x, y, and z directions respectively. This function represents density, which will be discussed in the next slide. Following that is my vector field, which represents more displacement the farther up the snow cone you go, similar to if you load a lot of ice above the cone structure itself. Finally is the tensor field, which is x1, x2, x3 in the diagonals of the matrix, and then x1 plus x2 in the left middle and top middle positions. I will show you a written version of this matrix later. On the left-hand side, you will see my MATLAB plot of my snow cone structure with each respective part labeled. One thing to note is that I shifted the cone from Project 2 to have the origin at the tip of the cone. On the right-hand side is my scalar field plot, which displays a lighter color in the more dense regions. I like to think that the heavier concentrations of flavored syrup lie in this part of the cone, like on the edge between the cylinder and the cone where the syrup might be dripping off the cone. Left is the vector field of my snow cone. As you can see, the farther up the structure, the vectors are gaining in magnitude, which makes sense because the cone has a higher possibility to tip over at the top where the ice is unconstrained from the cone. On the right is the vector field of the snow cone in terms of displacement. You can see the failure mechanism of the snow cone if too much ice is placed on the top of the cone. Also listed is my vector field written out. Here's the tensor field of my snow cone. This tensor field represents transforming the vector field seen on the last slide into a tensor field. As you move up the structure, the concentration of the field grows larger, which mirrors the result of my vector field. Also seen here is the scale bar, where the darker color represents the lower magnitude of the tensor field, and the higher magnitude of the tensor field is represented by the lighter colors. Finally, I would like to verify the results that MATLAB output for me. In the top left is my tensor field, written in component form, as well as the point I choose to analyze. This point was 2 in the x1 direction, 2 in the x2 direction, and 20 in the x3 direction. My tensor field with these values plugged in can be seen here. The bottom left displays me plugging in the x1, x2, and x3 values of my chosen point into the vector and tensor field. Finally, I chose to multiply the tensor field and the vector field values together to get a single vector of 20.476, 40.238, and negative 40.5, which matches the values found in MATLAB code seen over here. Next, I solved for the volume of the three shapes, including the cone, cylinder, and hemisphere, which came out to be a value of 2,153, which matches the value output from my MATLAB code. Thank you for watching.